Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face Trending List, published on July 21st, 2025, so just about 3 days ago. This paper introduces a new visual benchmark, where most state-of-the-art models achieve a 0% success rate. The paper is titled, Pixels, Patterns, but No Poetry, to See the World Like Humans, and the implications for how we train the vision components of these models are quite significant. The authors argue these failures aren't about reasoning, but a fundamental gap in visual perception. Alright, so how did these multimodal large language models actually perform on these tasks? This chart plots their results using a metric called pass at k, which basically measures if a model finds the correct answer in at least 1 out of k attempts. And what we see is pretty striking. Even when giving the models 32 chances, the accuracy for most tasks remains stubbornly close to 0%. The average performance across all of these tasks never even gets to 4%, really driving home the point that the models are consistently failing. Building on that, this table gives us the hard numbers for 15 different models, including big names like OpenAI o1 and Gemini 2.5 Pro. It shows their pass at 1, which is their success rate on the first attempt, and their pass at 32, or success after 32 tries. And what you see is just a sea of zeros. For nearly every task, the pass at 1 score is 0%. Even with 32 attempts, the scores barely move, with the highest scores only hitting a few percent. This really emphasizes the catastrophic failure across the board. So the big question is, why are they failing so badly? To figure that out, the authors performed what's called supervised fine-tuning. This is where they retrain specific parts of a model to see which part is the bottleneck. This table shows the results. When they only retrained the language part of the model, the part that reasons, the accuracy stayed at 0%. But when they retrained the vision encoder, which is the part that actually processes the image, performance skyrocketed to over 90%. This is the smoking gun. It shows the failure isn't in reasoning, but in perception. Okay, so if fine-tuning the vision encoder is the solution, what about a simpler approach? Could you just show the model a few correct examples to get it on the right track? This method is called in-context learning. This table shows what happened when they tried that, giving 3 models a few examples before the test. And the result was virtually no improvement. The scores for pass at 1 and pass at 32 barely move, staying stubbornly close to 0. This really reinforces the conclusion that the problem isn't a knowledge gap. It's a core perceptual failure. So to really see what's happening inside the model, the authors used a technique called GradCam. This basically creates a heat map to show what parts of an image the model is paying attention to. Before fine-tuning, you can see on top that the model is lost. Its attention is scattered across the image, looking at the waves in the sky, and it fails to find the word. But after fine-tuning the vision system, the bottom images show a huge change. Its attention is now laser-focused on the letter spelling love, and it gets the answer right. This visualization really drives home that the failure is perceptual. So to wrap up, what this work really shows is a critical blind spot in today's advanced AI. While these multimodal large language models are getting better at reasoning, they are failing catastrophically at basic visual perception. The core issue isn't their ability to think, but their ability to see. The experiments prove that the vision encoder, the component that processes the raw image, is the real bottleneck. This Turing Eye Test benchmark really highlights the need to focus on building models that perceive the world more like we do. That's all for this week's AI Research Roundup. Thanks for tuning in.